Hello, welcome to this video in our Oak Salvage project collection on measuring a sample in CooRecorder. Now that we have dated and scanned our sample, the next step in the analysis process is to measure the ring widths of the sample. Measuring ring widths is important to quantitatively identify marker years such as particularly narrow rings or periods of suppression. These data are later collected from other samples in the area to develop the site or region's overall chronology. In order to measure the ring widths, dendrochronologists use computer software such as CooRecorder, which uses an image file of the scan and provides selection tools to mark ring boundaries and measure a sample. Points selected in CooRecorder are recorded as coordinates, and the software calculates the distance from one coordinate to the next in millimeters or indices. The sample you see is from our Monmouth research and it is fully measured. So now I'm going to demonstrate how we can measure a sample in CooRecorder. So once we have our image file open in CooRecorder, we're going to go in and select data picking mode. So that's that D there. So once we click that, we're able to use our cursor as a selection tool, and then we'll find a ray to go along, and we'll select the edge at the end of the late wood for the most recent ring, and this will always be the ring closest to the bark. So that's the first step here. And then for the Monmouth samples, the year of the most recent ring is 2020 because the trees fell during the February 2021 ice storm. So after we select that, in 1 second here, so we type in 2020, and then now that we have that selected, we're able to go through the entire sample and select the boundary between the new year's early wood and the previous year's late wood, because the late wood signifies the end of a growing year. So you can see here we go along the ray and we're going to select the boundary between the last year's late wood and the new year's early wood. So that's the 2019 dot. Then now we're going to keep going through and select for each ring boundary. And we want to make sure that each selection is parallel to one another on the ray and the recorded distance of the true ring width, because if we end up jumping around and it's not parallel, then we're going to have inaccurate measurements. As you can imagine, if it goes like sideways, then you're not going to get the same measurement. And then rays will typically only last for a certain span of the sample, and so we can switch to a different ray with more than one point per selected line tool, and that's able to allow us to move to another ray and select more points on that other ray. So now that I've shown how to measure the first few ring boundaries, I'm going to go through the whole sample and measure each ring boundary, and for this process I'm going to speed up the video so that you don't need to see each individual selection, but you're able to instead see the overall process and you can see how it goes from the start to finish. And then I'll stop before it gets to the pith so that I can explain how we measure up to the pith. All right, now we've measured all the way to the pith. So we've measured through the whole sample to get our overall measurements, and we've made it to the set distance to pith tool step. So we're going to use that 3 circle tool right there to set our distance to the pith based on what we dated. So for the most recent ring that we just measured up until what we know is the center. So we're going to use these circles to estimate the distance there, and then we'll input in the number of years that we know up until the pith based on our initial dating. So for this, we have 1 year left until the pith. So once we put that in, we're able to get our final measurements. So now that the entire sample has been measured, we have a complete POS file, and this can be used to compare to other POS files for the same sample or for samples in the same chronology. And we can use one POS file for a sample as a reference file to compare to another. So right now I have the file that we just measured in here compared to a reference file for the same sample that I'd done earlier. And you can see that we have a 94% correlation with that .94 measurement for the correlation, and you can see specific years and specific measurements where there might be more differences, and we can see where there might be mistakes or inaccuracies, and we're able to compare that and see kind of how we can improve it before adding it to the overall chronology and get more accurate measurements. Thank you for watching this video on how to measure a sample in CooRecorder. I hope it was helpful and you get a better understanding of how our research process worked for the Oak Salvage project.